In this lesson, the target states I can use facts about supplementary, complementary, vertical, and adjacent angles to write and solve equations for unknown angle measurements in a figure. In the last lesson, we learned two big ideas. When a pair of angles are supplementary, when you add them up, you get 180 degrees. So two angles are supplementary if they add up to 180 degrees. And when two angles combine and form a 90-degree angle, or they add up to 90 degrees, they're called complementary angles. Two more things that'll be helpful to remember is that congruent means equal and corresponding means in the same location. So if I have two congruent angles, I'm telling you those two angles are equal. And if I have two angles that are corresponding, they're in the same general location on a different figure. We're going to combine that with all this new vocabulary, and we'll be solving problems in no time. The first word on the list is perpendicular. When two line segments or rays intersect, they form angles. If the angles formed by the two intersecting lines measure 90 degrees, then those lines are perpendicular lines. So perpendicular lines kind of look like this. We have perpendicular lines when the angles formed by the two intersecting lines form 90-degree angles. Next, parallel lines. Some lines in the same plane do not intersect at all. These lines are parallel lines. Segments and rays that are parts of parallel lines are also parallel. So, parallel lines are lines that will never going to intersect. So, they have to be the same distance between each other in all locations. So parallel lines are lines that never intersect. Skew lines do not intersect, and yet they are also not parallel. They lie in different planes. It's hard to understand by just drawing two lines, so I have to draw a three-dimensional shape, like a box. So here would be two lines that are skew. This line down here would be skew with this line up here. They're never going to intersect. They're on different planes. So if this was line A and this was line B, line A sits above line B. It's not on the same plane, so they would never intersect. Okay, a few more vocabulary. Vertical angles are the opposite angles formed by two intersecting lines. Angles 1 and 3 in the diagram below are vertical angles because they're opposite of each other. Vertical angles are formed when you have two lines that intersect each other, the angles that sit opposite each other. Vertical angles also have the same measurement, so it's helpful to know or be able to identify vertical angles because they're congruent. So if I know angle 1, I know angle 3 because they're congruent. Sometimes that can be helpful. And if I know angle 2, I know angle 4. A transversal is a line that intersects two or more lines that lie in the same plane. Transversals to parallel lines form special right angles. So when you have two parallel lines, like line A and B here, cut by a transversal, you get 8 angles. And there's a special relationship between a lot of those angles. So line C in this scenario would be the transversal. If two parallel lines are intersected by a transversal, there are some properties that you can memorize or remember to help you identify angle measurements or relationships between angles in parallel lines. So here's two things that are helpful to understand. If we were inside the parallel lines, or angles in here, are known as interior angles. Interior angles are the angles inside the parallel lines, versus angles that are outside the parallel lines. Those are known as exterior angles. So interior and exterior is referring to the parallel lines. But if we're thinking about the transversal, we could be on opposite sides of the transversal. So there are alternate angles. Angles that are on alternate sides of the transversal are known as alternate angles. Let's see if we can understand the properties of transversal to parallel lines. If two parallel lines are intersected by a transversal, like all the figures above, these figures, then corresponding angles are congruent. Corresponding angles are angles that lie in the same general location. So if I look at the green angles, for example, like right here and right here, those two angles lie in the same general location on those two figures, or those sets of angles formed by the transversal. These would be corresponding angles, and they would be congruent or equal. Alternate interior angles are also congruent. So interior means inside the parallel lines. That would be like this angle and this angle. They're both inside the parallel lines. So if this was angle 1 and this was angle 2, they are interior, they're inside the parallel lines, and they're alternate because they're on opposite sides of the transversal. Alternate interior angles are also congruent. And lastly, alternate exterior angles are congruent. That would be like this angle and this angle. They're exterior, they're outside the parallel lines, and they're alternate because they're on opposite sides of the transversal. So here we have three ways you can find congruent angles or equal angles when you have two parallel lines intersected by a transversal. Lastly, we have adjacent angles. Adjacent angles have a common vertex and a common side, but no common interior points. Angles 2 and 3 in this diagram below are adjacent angles. They're next to each other, and they share a common angle. When you put angle 2 and angle 3 together, you get half a circle because they're supplementary. So adjacent angles are supplementary. They add up to 180 degrees. So if I know one of them, I can find the other one, like in the example below. If I have 120 degree angle here, what would be the measurement of angle x? Well, I know 120 plus the measurement of x is going to equal 180 degrees. So here I'm using adjacent angles. These two angles are adjacent, and I'm using the property of adjacent angles, so the fact about adjacent angles, that they are supplementary. So to solve this, I would subtract 120 from each side. So x equals 180 minus 120, or 60. So if I can identify adjacent angles, and I know they're supplementary, I can put that together to help me identify the missing part. So I also have something else in this. I could label the parts of this diagram. This is 60. And this would be, since it's vertical, 120. And this would be 60 because it's vertical to what x is. So you see how you can put all this knowledge together to help you solve problems? Okay, now you try. Click pause and try these problems in your notebook, and when you're done, click play to check your answers. For numbers 1, 2, and 3, tell whether the lines are parallel, perpendicular, or skew. For numbers 4, 5, 6, and 7, if line R and line S are parallel to each other, intersected by a transversal, the transversal cuts through them both, use the facts about parallel lines in a transversal to find the missing angle measurements. Good luck. Okay, for number 1, we have to look at line JL and KM. Line JL would be right here in this direction, and line KM would be right here in this direction. Looks like line JL and line KM would be the parallel lines. So number 1 would be the parallel lines. For number 2, line LM and KN. Here's line LM, and here's line KN above it on this three-dimensional figure. Those two lines are never going to intersect because they're not on the same plane. So they would be skew. So number 2 would have been skew. And number 3, line LM, again, and line KM. Those two lines appear to be intersecting and forming right angles. So they would be perpendicular. So number 3 would have been perpendicular. Number 4, 5, 6, and 7. So the given information is that this angle is 115 degrees. So what would the measurement of angle 5 be? So angle 5 looks to be corresponding. It's in the same general location, but on the 4 angles below. So those corresponding angles would be congruent. So angle 5 would be 115 degrees. Angle 2 is opposite of the given angle. Opposite angles are congruent. They're equal. So angle 2 would also be 115 degrees. And angle 6, well, angle 6, they're both exterior. So this angle is exterior as well as angle 6, and they're opposite of the transversal. They're on opposite sides of the transversal. Opposite exterior angles are also congruent. So angle 6 would also be 115 degrees. So all three answers, 4, 5, and 6, are 115 degrees. So what about number 7, angle 1? So angle 1 and this 115 degree angle have to add up to being 180 degrees. So if I add angle 1 to 115, they are supplementary angles, I should get 180 degrees. So angle 1 is 180 minus 115. Or 65 degrees. So angle 1 equals 65 degrees. How'd you do? Great job.